Hello everyone, Bob Allen, Nortec Global Heating and Air Conditioning with a short video on microchannel evolution and why our innovation is leading the way in our industry.
Formicary corrosion, volatile prices, and demands for a greener solution have ignited the need for improved coils in heating and cooling products. The HVAC industry has been dealing with problems caused by combining dissimilar metals in their coils for decades. This combination has exposed manufacturers, distributors, and contractors to the added risk of reliability and longevity issues with products. 5 years ago, Nortec took on the challenge of finding a better and more environmentally friendly coil for air conditioning and heat pump applications. The answer came from the automotive industry. Manufacture coils with only one type of metal, aluminum. With the adoption of aluminum came several challenges. HVAC coils for the home are larger than automotive coils, and the coils needed to be bent and shaped to fit the application. Working with vendors worldwide, Nortec developed a solution, a new generation of coils that offers superior results compared to copper tube coils. Using a single metal means general corrosion is not a problem. Since copper is not used, formicary corrosion is not a problem. Because aluminum transfers heat differently, a fin configuration could be used, allowing for more surface area and better transfer. Tighter fin configuration means a smaller, more efficient tube can be run through the coil to achieve an equal distribution of refrigerant, requiring much less refrigerant than traditional tube and fin. Research, development, production, and testing of the all-aluminum coil have been a very slow scientific process. Thousands of hours in research and development have been invested to find optimum tube sizes, fin configurations, and headers. This work has led to a coil that is lighter, uses less refrigerant, and more friendly for the environment. Countless numbers of tests have been used to discover the optimal recipe of materials, heat, and baking to form the strongest and most reliable cladding of the coils. Coils start as raw aluminum coils. These coils are fed into a bender corrugator that form the heat, displacing fins to a tight tolerance. This fin configuration is the result of decades of engineering and testing to deliver the optimum heat transfer using the least amount of refrigerant. The corrugated fin then moves to an assembly table. At the assembly table, the process of lacing the tubes will occur. The corrugated fin stock is combined with MPE tube, which visually look like thin, flat bar stock with small holes end to end. The MPE tubes, which distribute the refrigerant, are lined up and packed tightly together for consistency, and then are fit into header tubes to form the assembly for brazing. Once the assembly is lined up, it is wire banded to increase rigidity and hold the assembly square. The wire bands are drawn tight for proper alignment and fin consistency. Next, the assembly moves to the brazing platform. The platform is then placed on the furnace conveyor and run through an automated flux spraying system. This system applies a precise coating of flux to penetrate and create the optimal brazing environment. Components that contain braze rings and specialized fittings receive additional flux per specific application specifications. The conveyor feeds the platform into the preheating and brazing sections of the furnace, where the coils are brazed utilizing specific recipes, accounting for such variables as speed, temperature, and size. Once the assembly has cooled, the coil is measured for accuracy. The completed coil is tested using helium leak test chambers. Once the coil passes leak testing, it receives a nitrogen charge and is capped. The coils are bent to their final specific dimensional requirement, installed into their respective units, and moved into the integrity leak chamber where the coil is pressurized with helium. After the unit holds the helium without decay, a highly calibrated helium detection device checks the integrity of the brazing. Helium is used because it has a smaller molecule than air, allowing us to find smaller leaks. The unit is then charged with the exact amount of refrigerant defined in the bill of material for that unit, and checked for leaks using a refrigerant detection device. Each unit must pass 4 leak tests, including a helium leak chamber and a helium sniffer test after brazing. After the unit is charged with refrigerant, a refrigerant sniffer ensures there are no leaks. At the end of the line, completed units receive a final box leak check. The unit must pass all leak checks before it is approved to ship. During the entire coil manufacturing process, the manufacturing lines are constantly gathering statistical inspection data, performing quality audits, performing periodic destructive testing, completing scheduled maintenance activities on the manufacturing equipment, and conducting laboratory analysis of brazed joint integrity. Documentation and records are reviewed based on strict schedules, and process performance is analyzed to ensure optimal results. This next generation of coils delivers contractors and consumers alike a new level of efficiency and reliability. Just one more way, we are helping to create satisfied customers and a greener planet for future generations. Nortech Global HVAC, creating a better tomorrow every day.
Hey guys, just want to thank you for watching. Thank you for your business. Be safe out there, and we'll see you soon. Take care.